Design problems are very common during software development. How do you choose the right software or a technology? How do you select the most suitable algorithm or the data structure? How do you optimize for performance? Now, there's design patterns and then there are architecture patterns. We are going to be talking of architecture patterns. The difference lies in the abstraction. Architecture pattern is still at the top, while design patterns are more granular and help you make more day-to-day choices. So if we talk about architecture patterns and design problem patterns, there are fundamental semantic differences between them. Architecture patterns operate at a higher level of abstraction, while design patterns are lower level and are mostly focused on the implementation of a software. There's a good tabulation between them. So the definition is fundamental structural organization for software system, while design patterns are more of specifications that could lead to implementation. The roles are, converting high level characteristics of software system to a structure, while when you talk of design pattern, there's a detailed description of all the units the software system needs to have to be able to support coding and delivery. If you think about it, architecture patterns, if you take this definition, and there's a lot of ambiguity in the definition. Some people will call this there's five patterns. Some people will say architecture design patterns, some people will say architecture patterns, some of them will say design patterns. So there's a lot of ambiguity, but let's try to debunk some of that. Example: microservices, serverless, event driven, layered. These are some of the architecture patterns. When you talk of design patterns: singleton, structural, behavioral, creational, object oriented. These are some of the design patterns. When we talk of level, it's still a high level software architecture pattern, but the design patterns are very, very low leveled, and they give you enough details to build a subsystem, as the definition says. They address different problems. I think the architecture patterns solve more from a reliability. Common seen practices and challenges are usually what gets converted to an architecture pattern, while design patterns are more focused towards construction. So you could think architecture patterns are more conceptual and abstract, while the design patterns would be more tangible and concrete towards development. Some of architecture patterns are layered architecture, client server, microservices, microkernel, MVC, event driven, and so on and so forth. So the first pattern that I want to talk about is layered architecture. Now, how do we define layered architecture? There's multiple different layers in your system, layer 1 to layer n, and these could be different layers, right? This is just one example where you have a presentation, application, business, persistence, and a database layer. You could have more layers into it, right? And each of these layers might follow their own dedicated software architecture. For example, the application layer might follow something like a microservice, while the presentation layer is an Android and follows MVVM. So layered architecture is more of a construct where you add multiple layers in the system. This is very commonly seen in high risk applications or critical applications, something like a finance application, where the data is typically to be hidden behind multiple layers, and they'll add layers of integration on top of core systems, which sometimes go multiple, more than 3-4 layers in fact. So this can get really complex depending on type of system that we are talking. Moving on, we have a simple client server architecture. There isn't much to talk about it. There's a client, there's a server. It's a straight TCP/IP communication. That's what a client server is. Sometimes people think of client server as master slave, but they are actually different. Client server usually implies one client and one server, but a master slave could be master and multiple slaves. So that's kind of a different architecture, and slaves follow typically more of a dumb terminal concept. So that's also an architecture pattern. I think I have not included that here. Very popular from good old days, MVC pattern, model view controller. Typically you get an input which is fed into the view, and then you have a view controller which is determines what needs to be done, and if there's a data which usually is, kind of goes and queries a model. View can also update the model depending on scenario. This is what it talks to the database. These are very traditional database these are very traditional patterns. Some again, going on the borderline of abstraction and risking the semantics again. There's more patterns like MVVM, which is model view model, which is focused in more modern persistence layers, and there's a kind of a data binding which happens. So it's an architecture pattern itself, might be a design pattern. I really follow the principle of what works, let's just continue as long as you get the answer. I don't get into semantics too much, but sure. This serverless pattern, very popular for the past few years. I think this and event driven both. So serverless is typically there's a client, and some of these are often mixed. I want to call out event driven serverless and messaging patterns. They are quite distinct message parsing interfaces versus event driven versus serverless. But sometimes what happens is they use there's usually a mixture of couple of these patterns happening. So it's very much possible that there's an application, event driven application, where a part is microservices. I think I forgot to add microservices should have been here. I'll talk about it. So then there's so the way it gets mixed is there's a part of the system where an event is getting generated, part of the requirement is fulfilled by serverless, and part of it by microservices. So that's I think I want to call that out and be cautious about it. So there's a client, there's an API gateway, there's a serverless function, and serverless function is typically something which is not always up and running. Usually there's a warm up in requirement happening. So there's an endpoint, when you hit, warms up, does what it needs to do, and comes back. So it's not like an always live. And the beauty is if there's, let's say, 50 calls, you will only be billed for 50 calls instead of running a 24/7. If this was a microservice or a monolith application, it would be running all the time typically. So that's the beauty of this. And then there's a API gateway can also go and work with a legacy load balancer, legacy app, and legacy database. Fauna is just the name of a database. Then there's event driven. There are sources which generate data. Then there are publishers, something like Q or a Kafka, which is very popular. Then the data is stored into an event data store. Sometimes the Kafka also provides a degree of storage for a certain number of days. If you want persistence, you can have an event data store. And then there's a subscriber which kind of subscribe to the data or the channel, and it can do a variety of actions basis that. It can throw the data in a sink, it can send it to a file system, it can send it to an app, blah blah blah. This is also, event data store is also connected to a subscriber and publisher, which is kind of altogether a different world there. Let's talk of microservices. Microservices, I typically follow Chris Richardson for his concept. So we'll just take a quick copy this image, put it here, and off we start. So this is an example of a system where there's an API gateway. There are 3 services. There's an order service, there's delivery service, and then there's consumer service. What's happening here is that the calls are each service. What he's showing is, this service is calling this service. This is getting called by the gateway. This is calling this. So each services are also calling each of the different services, but they are completely independent and isolated units. For example, if order service goes down, the delivery service can still work, right? It's connected to API gateway, and consumer service can still work. The whole functionality would come to a halt, and that's always tricky when you design a microservice based architecture, because the inter or intra dependencies of one microservice on another could sometimes lead to a failure in the whole system. So you have to design it in a way which where there's some sort of a graceful degradation happening in the system. But that's the whole idea of a microservice. So this is what microservice is. Now patterns as a whole have usually been blown up in my view for quite a lot. These are some of the things which are really standard and foundational. I think one good read on an article would give you or watching this video would give you a good understanding of it. So just to recap, what have we looked at? We have looked at layer architecture pattern, client server, MVC, serverless, event driven, and microservices. There's a couple of more architecture patterns like microkernel, distributed systems, and each of them get into more specialized conversation. There are some really good articles. I'd like to call them out. So this is first. This is a really old article written somewhere in 2017, but it talks of 10 common software architecture patterns in a nutshell. We are not going to take a look at this article. I'll probably do a whiteboarding session. This is usually a good reference point. It has quite a good 38,000 claps also. Let's just add to that. So yeah, that's one. Red Hat has a good Red Hat has a good repository of articles around these things. Most people don't know that. So there are 14 software architecture design patterns that Red Hat prescribes. You can take a look at that, and these are some of the links, and they have detailed links for each of them. Then there's 5 essential patterns for software architecture, which is given by Red Hat itself. I think it's best to refer to the 14 version. Now let's go and hop over to understanding what some of these patterns are, right? So that was the video all about. Thank you for watching. If you have liked the video, please do subscribe to it. If you have a question about any of these architecture styles, I'm probably try to do a video in depth on each of these with a live coding example and something like that. But if you want to know of anything specific, please do put in a comment. And with that, Akash signing off. Bye-bye.